Hello and welcome to another exciting chemistry session. So we continue looking at more concepts. So as of today, we're going to discuss how to calculate the mass in chemical equations. How to calculate mass chemical equations. How to calculate mass in chemical equations. So to calculate mass in chemical equations, we use two methods. Method number one is known as the law of conservation. The law of conservation of mass. And the second one, so that is the first one. The second one involves the use of stoichiometric moles, mole ratio, stoichiometric or mole ratio. So these are the two methods that we use to calculate mass in chemical equations. So as of today, I am only going to discuss the law of conservation of mass. So the law of conservation of mass states that, so this law states that the mass of the reactants is equal to the mass of the products, provided the chemical equation is balanced. So at this level, the balancing of chemical equations should not be a problem. So at this level, we need to know how to balance the equations. So I'm going to demonstrate the meaning of the law of conservation of mass. The meaning of the law of conservation of mass. So we have a reaction, for example, a reaction of hydrogen plus oxygen giving us H2O. So provided that this equation is balanced, so how do we balance this equation? So we put a 2 here. So provided that this equation is balanced, the mass of the reactants and the mass of the products should be the same. That is what the law of conservation of mass states. So mass can never be destroyed or created, but it can be transformed. So the mass is always maintained. When you look at the mass of the reactants, it should equate to the mass of the products. So using the relative molecular mass, you know that 2H2 means that you have 4 times the mass of hydrogen, which is 1. So this will give us 4. So we have the 4 here, plus the relative molecular mass of O2. So O2 means we have 2 times 16, and this will give us 32. So on the reactant side, we have 32 plus this plus 4, this will give us 36. What about the product side? So the product side, we have 2H2O. So this means that you have, there's a coefficient which is a 2 here. So it means that 2 times 16, giving you 32, and then we have 4 hydrogens times the mass of hydrogen, which is 1. This will give us 4. When we add these together, they will give us 36. So this is what this law tries to communicate. So the mass of the product and the mass of the reactant are always equal, provided the chemical equation is balanced. We can look at so many chemical reactions to try and prove this law, and we find that we definitely get the proof, provided the chemical equation is balanced. Let us look at another example, just to prove the law of conservation, the law of conservation of mass. Just to prove the law of conservation of mass. Let's look at the reaction of nitrogen plus hydrogen, giving us ammonia, which is NH3, giving us ammonia, NH3. So balancing this equation, we put a 2 there, and we put a 3 here. So we are looking at the reactants, the overall mass of the reactants and the overall mass of the products, if they are equal according to the law of conservation of mass. So N2, what is N2? So N2 simply means 2 times 14, giving us 28. This gives us 28. So we have 28 plus 3H2 means we have 6 hydrogens. 6 hydrogens times 1 will give us 6. So plus 6. 28 plus 6, this would give us 34. This would give us 34. Does it equate to the mass on the product side? So on the product side, we have 2 NH3. So how many hydrogens do we have? So hydrogens will have 2 times 3 there. That will give us 6 by 1, which is the mass of hydrogen. Then this will give us 6. Then here we have a coefficient in front, so it means that we have 2 times the mass of nitrogen, which is 14. And this will give us 28. So when we add these two together, we find that we get 34. So this is what the law of conservation of mass is all about. It states that the mass of the product should be equal to the mass of the reactants, provided the chemical reaction is balanced. So we're going to use this law to answer to calculate the mass in an equation. To calculate the mass in an equation, we can look at an example. I'll just try and create some examples that are so it's a 200 grams of hydrogen reacts with O2, which is oxygen, to produce water. Say calculate the mass of water. Calculate the mass of water produced. So definitely there is an equation. So definitely there should be an equation. So an equation is H2 plus O2, then this would give us H2O. So the first thing you have to do is first thing you have to do is balance the equation. Always balance the equation. So balancing the equation, we'll put a 2 here, which is a coefficient, and we'll put another 2 there. So that is a balanced equation. So the first thing is you balance the equation. Always balance the equation. Always balance the equation. If the equation is not balanced, then you cannot get this question right. So calculate the mass. Then this is the mechanism. So in these questions, there is always a mass given. In these questions, there is always a mass given for a certain reactant or a certain product. So that element or that compound whose mass is given, we consider it to be the known. So there is always the known. There is always the known. So for the known, the mass is given. Then there is the unknown. So the unknown is what they are asking you to calculate. So the unknown is what they are asking you to calculate, and the unknown comes from the question. So you identify what is the known, or which one is the known, and identify which one is the unknown. So when you look at this question, the known is hydrogen. So how are you going to pick the hydrogen? So you pick hydrogen the way it is together with its coefficient as 2H, 2H2. Then this will be equated to the unknown. Which one is the unknown? So the unknown is what you're calculating. So what you're calculating is the mass of water. Therefore, you pick water again the way it is together with its coefficient. So you have 2H, 2H2, 2H, 2H2O. Then what is the next step? What is the next step? So the next step now is to find the relative molecular mass. Relative molecular mass of each. So find the relative molecular mass of 2H, 2H2, 2H2, which will be 4 by 1, 4 by 1, giving you 4. So you say, for this one, I'm getting a 4. Then for water, which is 2H2, so together with its coefficient, when you do your calculations, you find that it gives you 36. It gives you 36. So you're going to have 36 on the other side. Then for hydrogen, the mass is given. The mass is given. So you have 200. Just to be very consistent with the units, 200 grams. Then on the other side where you don't know, you say X. And from there, you just use mathematics by cross multiplying. So after you cross multiply, you're going to have 4x is equal to 200 grams times 36. So divided by 4, divided by 4. Cancel the 4, therefore your x will be equal to. So now you can use your calculator. You can use your calculator. So you say 200 by 36, 200 by 36 divided by 4. So that will give me 1,800 grams. So this is grams of what? Of water. So you have found the mass of water. You have found the mass of water. So basically this is how we find the mass in chemical equations. The first thing is balance the equation. Once you balance the equation, identify the known and the unknown, then find their relative molecular mass. Then you can proceed find the, you can proceed to find the mass. We can look at more examples. We can look at more examples in this book. So law of conservation of mass, just stating what it means, and then what is the procedure, what is the requirement, what is the requirement. So always you can prove the law of conservation of mass by balancing the equation. Then you find the mass of the reactants and then the mass of the products. You find that they're always equal. Now, when using the law of conservation of mass, as I was saying, the first thing is make sure that if the equation is not provided, write the equation, balance the equation, identify the known, identify the unknown, find their relative molecular mass, that is for the known and for the unknown, then you can proceed to find the value of x. We have an example right below. This is the example. We have a reaction of 10 grams. This is an example. A reaction of 10 grams of hydrogen reacts with oxygen to produce water. Calculates the mass of water. So this is similar to the example that we're looking at. So we have a reaction of H2 plus O2, and this is given as H2O. So the first thing is balance the equation. You put the 2 there, you put the 2 here. So they have given you 10 grams of hydrogen. So just get hydrogen the way it is together with its coefficient. So you're getting this and you are getting this. So together with its coefficient. So it becomes 2H2 and 2H2O. Then you find their relative molecular masses. So relative molecular masses will be 4. This will be 36. This will be 36. Then you have been given 10 grams of hydrogen. Then on the other side you just say x. So what do? Cross multiply. So it becomes 4x. 4x is equal to 36 times 10. It becomes 360 grams. So divided by 4, that will give us x is equal to 90 grams. So that is 90 grams of water. That is 90 grams of water. So it's a very simple procedure. Just make sure that you pay attention to the coefficients. So you pick the element or the compound together with its coefficient. Then you find that you walk over a question. So after doing the calculation, you find that you get 90 grams of water. So you can look at different questions. Like when you look at question number 2, they give us a reaction of magnesium reacting with oxygen to produce magnesium oxide. So in the question, just identify the known and the unknown. So in the question, we have magnesium. We have been given 200 grams of magnesium. And then they want us to calculate the mass of magnesium oxide. So you balance the equation, meaning you pick magnesium the way it is, and you pick magnesium oxide the way it is, and then find their relative molecular masses. So 2mg and 2mgo. So again, you can use the principles of mathematics. You have the same coefficient, so you can divide the coefficient to write it in the simplest. simplest form so that it remains Mg remains Mg and MgO. Mg. So here you have 24 as the mass, the relative molecular mass. Then magnesium oxide, so that will be 1 times 16, 1 times 16 giving you 16. Then 1 times 24, 1 times 24 giving you 24. So when you add those together, they give you 40. So on the other side you have a 40. Now if you have 200 grams of magnesium, 200 grams of magnesium, you say X. What should we do from there? You cross multiply. So this becomes 24x. 24x is equal to 800 when you multiply 800 grams. So divided by 24, divided by 24 throughout, the x and the x will go, the 24 and 24 will go, meaning the x becomes, so 800 divided by 24, so you get 33.3 grams of magnesium oxide. So it is a walkover question when you're asked to find the mass. So this is 200, this is whatever, this will give us 80. So we used 80 by 200, yeah, so we get 333 0.3 grams. So this is what we're supposed to get. I think I overlooked the 0 somewhere. So this is how we calculate simple and straightforward. We can look at a lot of examples and find that it is the same procedure. So there is always a mass given. There is always a mass given, and then you're asked to find the mass of what is missing. Like in this case, we have the thermal decomposition of, the decomposition of calcium carbonate. Calcium carbonate decomposes to give you calcium oxide and carbon dioxide. So in the question you are given 400 grams of carbon dioxide is produced. Calculate the mass of calcium carbonate. So you just get carbon dioxide, which is mentioned, and calcium carbonate. When you find their relative molecular masses, relative molecular mass, this is 44, that is 100. Then you are given 400 grams of carbon dioxide. So when you cross multiply, definitely you get 909.1 grams of calcium carbonate. So we find a lot of these questions in chemistry papers, and that is just the way about. So sometimes they try to confuse you by not giving you the mass in grams. Maybe they give you the mass in tons. They can give you the mass in tons. They can say copper plus O2, then we take it that it's copper 2, we get copper oxide. So balancing, we put 2 here, we put 2 there. Then maybe they give us maybe 6 tons. Instead of giving us mass, they give us 6 tons of copper. Give us 6 tons of copper. asks us to find maybe the mass of, let's say, find the mass of oxygen that was reacting. Find the mass of oxygen that was reacting. Mass of O2. So the principle still remains the same regardless of whatever they give you. So just know what is known, and know what is unknown. So what is known is a 2CO, and what is unknown is the O2. So what is 2CO? So what is 2CO is 2 times the mass of copper, which is 64. 64. So a 64 by 2, 64 by 2, you get 128. Get 120. So you just put 128 there. Then O2, we know that O2 is always 32. So if they give you 6 tons, once you can put 6 tons there. You can maintain the units and you say X. You cross multiply. This would be 128. 128x equal to, so 32 by 6. 32 by 6 would be 192 tons. So remember, you're dealing with tons. 192 tons. So this can be divided by 128. Divided by 128. Therefore, your x will be equal to 192 divided by 128. So that will be 1.5 tons. 1.5 tons of oxygen. 1.5 tons of oxygen reacted. Or if you're not comfortable with the tons, you can convert the tons to grams. And the conversion scale is 1 ton. 1 ton is equivalent to 1 million grams. So you can use this conversion scale if you're not comfortable with the tons. So basically, that is how we calculate the mass in chemical equations using the law of conservation of mass. So this has been your host, Mr. Monsa. If there are any questions, feel free to ask the questions in the comment section down below, and then you will be helped. So in the next chapter, we'll try to talk about how to find the mass using the stoichiometric moles or the mole ratio. Bye bye.